I think we can start. So as I was telling you, you can write on the chat or in the question and answer. And yes, if you cannot hear me, you can write on the chat. That maybe if you cannot hear me. So today I will present to you a really very quick overview on semantic technologies and OWL and the various technology you will find. And then we will go through a couple of, yes, I think around 10 examples that I sent you the link at the beginning. So you will see this. You will see this. I will show you this practical example in Fluent Editor. So let's start by this overview over semantic technologies. And so I will speak here about the web ontology language, RDF, and Sparkle. I hope that you already have some kind of notion of this, because this will be very quick. If not, maybe I will. You can make answers. You can ask me. Seems that some people have problems hearing. Okay. So let's start. So the first thing is description logic. So this is underneath what is underneath OWL and okay, great. So the link is at the beginning of the chat. You can go up in the chat. Maybe you cannot see. I will send this to you again. At the end, we will send this to you again. Okay. So description logic is what is underneath OWL. So it's what is used in semantic web, and it's a logic that is used to describe semantics. And then in description logic, there are a couple of things that are difficult to generally grasp, and we will approach this from a practical point of view. And this is that you have no unique name assumption, and there is and this means that if you write something, a concept, for example, more than once with the name is not identifying the entity. And then you have open word assumption. So open word assumption means that if something is not stated, it is unknown. So as some people are saying that the volume is not very good, like this is better. You hear me? Okay, so I will continue with this mic that maybe. Okay, great. So we will continue with this mic. So then you have the open word assumption, and open word assumption is saying that it's saying that if something is not stated, it is unknown. We never know. Then you never know if something new about the statement will come up. So this is why open word assumption is used, because it's used by the reasoner in order to be always ready for something new that can come up. And then it gives also the possibility to extend the language, but it is generally counterintuitive. So this is the introduction for OWL. So what is OWL? OWL is it's a ML language really for expressing semantics, and underneath OWL we have DL, as we already said, and we have owl is divided in profiles by it's a standard, so it's divided in profiles and there are various profiles. And the profiles we have owl full, and owl full is some kind of it's a way in which you can describe facts about ontology, or you can like do some kind of meta ontology modeling. Owl DL is what is generally used is the full DL, so the Stroiku implementation of Owl, and Stroiku is one of the possible DL dialects. Then you have various restrictions that are generally defined for optimizations and for having a better performance. So there is Owl EL, QL, and RL. Let's say QL is generally optimized for querying, while RL is a dialect, such as a profile that should be used for, it's the more efficient for rule languages. So it's a dialect that has been defined in order to in order to be processed by rule and join. So having as underneath OWL there is DL. OWL is benefited from many years of DL research. So there is a well-defined semantic. Then there are the formal properties are well understood, and there are reasoning algorithms, known reasoning algorithms, and there are implemented systems that use this. Then we have that OWL is there is a definition. This image comes directly from the OWL standard, and this is the definition of the ontology structure. So how the ontology structure should look like. And as you see here, you have that there is an ontology. This is the definition. So an ontology is something that can be annotated by annotation. When you have a star in this arrow, this means that it can be done how many times you want, so to the infinite if you want. And then you have the ontology is defined also. It can have an ERI and it has inside action. And each action can be annotated. And again, how many times you want. One interesting part that generally maybe not everyone knows about is that ontologies can import other ontologies or directly import other ontologies. So this difference is it's not very clear. So import means when you are in an ontology, you have two ways to referencing other ontologies. One is by importing it. So if you import this ontology, you will import the other ontology plus all the things that are written in this other ontology, while you can only reference this ontology. And in this case, you will use for example, you use some prefix or some namespace, but you are not really importing the ontology into the ontology you are writing. This is very important from a reasoning point of view, because if you import an ontology, the reasoner will need to reason over this ontology plus all the ontologies you have imported. If you are not importing it, but just referencing it, the reasoner will reason only based on the ontology you are currently writing. So then another important part that comes from the standard is the annotation. So annotations also has a specific structure. So an annotation can have an annotation property. Then it has a value, and the value can be an IRI, a literal, or an anonymous individual. And then, as you see, the annotation can be annotated as many times you want. So the annotation is annotating some property. The property, yes, can be whatever you like. So this was just for OWL. So as I was saying, I have been very quick. So then now I will show you just another very quick introduction of RDF. So what RDF is. In general, RDF is XML format, but it's a way to express relationships that can be represented on a graph. So instead, while OWL is a way in which you can describe full semantic, in the RDF case, you cannot describe everything. So OWL is a superset of RDF. And we will see an example in which we will show you that what this really means. So in general, RDF you can see as in a graph. You can represent everything in a graph. So in this case, I have taken some sentence and I represent this knowledge, let's say, in RDF. So in RDF, this can be represented like this. This is really a graph database if you look at it, but RDF is just an XML representation of this. So you have that John is a person, Mary is a person, and then they are related by this event. As you see here, I've taken a quite complex example because in this case we need some kind that is called a blank node. That is a node that we need in order to connect these two book and frog from the same sentence. Because in theory, a graph database, if you take without blank nodes, you can describe only binary relations, while with blank nodes you can go also to more complex relations. So RDF has two parts. So there is RDF and RDF schema. So where in RDF schema there is a definition of simple semantics in which you have a relation between elements of RDF. Then it has a graph representation and it is compatible with a graph representation. But in general, there are things that can be expressed in OWL but cannot be expressed in RDF. I will show you after which one of them. There are some things that you cannot express in one of the two. So then the third part, the third standard that I would like to present is Swirl, SWRL. And Swirl is a rule language, and it's incorporated into DL, just that the part that is inside OWL and RDF is the DL safe part of Swirl. So if we take the things that you can express in OWL, the things you can express in Swirl, you have that there are things that you can express in both of them. So there are things that you can express in OWL that you cannot express in Swirl. There are things that you can express in Swirl but you cannot express in OWL. And the DL safe part is some kind of subset of all the things you can define in Swirl. As you see, in general, DL safe means that it's a rule that cannot create new instances or cannot create new things that will be put back in the ontology. So this is in general what is DL safe, and it's a way in which you can have sound and complete reasoning. So this is why it has been added to OWL, because the DL safe part has been added. Because in this way we know that this is that still the reasoning can be done on this. There is an extension of Swirl that are the Swirl built-ins, and these are some functions that extend the capability of Swirl. It's not really clear what these built-ins, how they change the graph I was showing you before with OWL, Swirl, and DL safe. So this is why there are some reasoning that do not support it. So there is, and this is because, for example, the Hermit guy told us that the problem they have with this is that there is no theoretical assurance that it will be complete if you add built-ins. So not all reasoners support it, but in Ontology and CNL we support this, and they are generally divided in many categories. For example, you can have built-ins for comparison. There are math built-ins, Boolean strings, date, time, URIs, and lists. And so depending on the built-in in general, these built-ins can be used to manipulate things inside the Swirl. inside a Swirl rule. So, for example, the one for comparison is built in which inside a rule you can compare values, or the date time is some function that inside a rule you can find for example, compute compare some value to the last month, for example, of things like this. Then the last one, and again, I tell you this is very quick. So if then you have questions, I can go further on about this. It's Sparkle. So Sparkle is it's a query language, and it's a language for querying graph databases, and so in general triggers also RDF. You can using Sparkle you can express graph patterns and also graph transformation depending on the what you are using. And then in Sparkle the syntax is very simple. You are just this maybe my quick syntax is very simple. So you have a prefix in which you define the relation between namespace and prefixes. Then you can do queries like select, construct, or ask, in which select will retrieve some subset of your data, construct will build a new set of triggers, and ask will give you back a Boolean answer, true or false, if the graph pattern inside was fulfilled. And then you have the content of the query, and then you can add things like filter, limit, and things like this. So if you see a Sparkle query, it looks very similar to SQL, and so it's very simple to start working with it. Also, if you don't know anything about RDF and all the semantic work, still it is important to remember that underneath Sparkle works very differently. So this is very important when you search for efficiency, because you need to start to think of how actually the query is executed. And if you think in an SQL-like way, you will find that very quickly that your Sparkle query will take a lot of time. I see here a question about Swirl and Spin. So Spin it's some kind of to my understanding, I'm not an expert about this, but it's an ontology that defines formalize a way to use Sparkle to reason. This is more or less what I have understood. So it's more, there is no real relation between Swirl and Spin. The relation is more between Spin and Sparkle, I think. And then Spin is some kind of implementation that is used to implement some kind of rules. Oh no, yeah, you're right. So there is a relation. But Spin, to my understanding, is implemented in Sparkle. So then, this is a simple example of a query, a Sparkle query, what is happening behind the scene. So let's imagine I make a query in which I define two simple prefixes, and I say select, and I want these two variables where the John as these two, the property and this value. So again, this seems like SQL query. The problem is this, that this is actually, you are writing a graph pattern. So you are telling the engine, you are telling him, please find the places in the graph where this is one of the nodes, and this node is connected to is as a link to another node. So in this case, you will start if the engine is good, so you will have some kind of indexing over your nodes, and so it will understand from the whole graph. You will find out the nodes John, and then the next step you will say, okay, you ask me then all x, so it will follow the two links and say, okay, the two x that you want is our RDF side, and then you see that you ask him also the y, and so it will also retrieve the two things, the two nodes that are here, and so you get back this answer. So as you see, this query is very simple, but if you start to think that this can be a very complex graph, so in this case also the graph is a tree, so this is very simple, but in very complex case, the graph can have loops or things like this. So if you start to think in this way, you will soon find out that when you write a query, you can start to think of why your query is so slow. Then it's not so simple. It takes some time to see these things. Okay, so this is all. So now I will go to the practical examples. So the practical examples, I have a couple of them. So I will start by the first example. You can download this. I sent you the link. So if you have downloaded this, the first one I will open is this file that is called owl not in RDF. Oh, maybe I will write this down because okay, so it's owl no. Again, so I will open this file. Let me find it here. And so the first thing that needs to be said, to be told here, is that I opened this file in, I gave you a encnl file. This is a file written in Ontology natural language, and this is a controlled natural language that we have implemented here at Cognitum to that is mapping to OWL. So, for example, and then I opened this in Fluent Editor. Maybe you already know this, and this is a tool using which you can modify ontologies. So, in this case, you can see immediately that this sentence here. In the XML preview, you see that the sentence is translated to some OWL sentence. You can also translate this to RDF if you want. And here, this one also, and this one also. Okay. So then in Fluent Editor, you have the reasoner where you can ask questions and materialize graph with those with. So let's start by what this file has inside. So this file has inside 3 sentences, so nothing more. Okay, let me see. Because this microphone, where is this? Just a second, I will try to put this microphone in a way that is stable. So, here we have 3 sentences. So I have written that this, in CNL, when you write something with an uppercase, it's an instance. When, in this case, I have said that this instance 1, has some property, and this property is a concept. So I have written that instance 1 has value a cat. Then I have written, for example, that instance 1 has cardinality at least 1 mouse. You can see this in OWL. So this is an object mean cardinality. So I said that this named individual, instance 1, has a mean cardinality for this particular property of 1. And it should be also a concept mouse. And then you have that, and this other, for example, I've written that instance 1 has some value greater or equal to 1. And here you can see that this translates to data some values from data type restriction, and it's a set restriction in which you have 1. So these 3 sentences seems quite innocuous, so not very interesting. What can be interesting, and what I want to show you here, is that if you go in the Sparkle tab, and in the Sparkle tab we are materializing a graph. So we are taking everything that is written in your ontology, and we are reasoning over it and materializing everything that is possible in a graph. So everything that is you will get back from Sparkle, the Sparkle tab or the Materialized Graph tab. It's something that comes from a graph. So and as we said before, a graph is RDF. So if you do here execute, we will materialize the knowledge. Oh, now I got some. I will come to this after what this message will mean. But because right now I wanted to show you something else, so I will go in the mode so that there is no problem. And let's do for everything. So I will ask for everything that is inside this file. So this is generally a query that you should never make in no RDS graph, but in this case it's very little. So let me say, so here I have asked my engine, Sparkle engine, to give me everything that is inside the graph. So I got back all of these very nice things, only that if you see, this is my property, and the properties that are here are these standard properties. But for example, as you see, I am not, there is not the property has volume, there is not the property has cardinality, and there is not the property has some value. So you can imagine why. But the file name is quite explicit. So it's not in there because these are sentences that can be written in OWL, and there is no problem with this. Just that they cannot be written in RDS because there is no way to express such kind of let's say generic fact. So in this case, how you define in a graph, how you define that instances cardinality at least one mouse. Let's say like this, in an RDS graph, because in a graph in general you can also describe these kind of things, but in an RDS graph you have no way. So this is a very simple example, just to show you this kind of limitation of a graph, representation of the knowledge, and the DL, description logic, the full OWL description logic representation of the knowledge. Okay, so this for this file is enough. Again, if you have more question about this, I can answer. Then the second one I will show you is inconsistent reasoning .emcnl, and okay, so this is a file. It's a file in which I would like to show you all kinds of inconsistent reasoning that you can create by writing an ontology. This I think is interesting because not always people think when writing an ontology or taxonomy or things like this, not always think about if then the things that you have written down will be inconsistent or not. And then I think it will give some idea on problems you can encounter while reasoning. So in this case, I am in the reasoner tab. This reasoner tab is a tab in which you can reason. So I take the ontology, and in this case, for the reasoner tab, we are using HasKey. So it's full DL reasoning. So in this case, I click enter, and you see, I have an inconsistent knowledge, and it's written reasoning is impossible. So the first thing we need to understand is you understand why, but maybe this is simple. So I have written these sentences, and I said that John is a young man, John is an old man, and then somewhere I have written that no young man is an old man. So if you want to see the OWL version of this, you can see that this I said that a young man is a subclass of the complement of the old man. So in some way I've said that in my word no one can be at the same time a young man and an old man. So this is why my reasoning is inconsistent. So the second step is that I want to show you is that what happens if you write something like this. So in this case, I am commenting out. Comment is what you think it is. So comment is commenting out this sentence from the ontology. So it won't be used by the reasoner. And then you can do like this. And again, my ontology is inconsistent. As you see, I am just showing you many ways in which the same ontology can be inconsistent. So So here you have, for example, I wrote that something is a man if and only if it either is a young man or an old man. So if you see the owl equivalent, this is a disjoint union of these three. So that man is a concept that cannot be at the same time an old man and young man. But the strange thing is that maybe it's not completely obvious, is that I have not said that John, I have not said anywhere I have written that John is a man. So this means that, so maybe you could think, why this is not working. So the first answer that maybe it's not completely an answer, but we'll start by this. So a first answer is that the sentence we were writing there is equivalent to these three sentences. This I will go a bit in detail into this. So in this case, I've written every man. What I want to show you here is what this joint union was actually doing. So what it was doing is that before it was this sentence is equivalent to this three. So it was saying something like that man is a young man and or is an old man. So that you say that man is a subclass of the union of these two concepts. Then it's saying that no old man is a young man, and then it's saying that every single thing that is a young man and or is an old man is a man. So in this case you say that subclass of the union of these. So you say the contrary. So just to be clear, I have prepared a simple explanation for this, and then maybe we can see. So just to be clear, so what I am saying is this, that the first sentence is saying something like this. It's saying that you have a young man concept, you have an old man concept, and the man is something in between. And this young man and old man can be overlapping. Then we have a sentence that is saying that no old man is a young man, and so we are dividing this word into. So we have that young man and old man are two divided things, and then man is there in the center, still between the two. And then we have this other sentence that is saying the contrary. So it's saying that before we said that the man was subconcept of the union, and then we said that the union is a subconcept of the man. So at the end we end up with something like this. This is very bad sentence that I don't think that you will ever write an ontology like this, but it's more to give you an idea of what you can achieve or should not achieve by using this kind of language. Okay, the last thing I will show you, and this is it's really, I don't think it's very interesting, but what I'm just showing you is that you can also say something like this. For example, you can define some property range and say that has name as a property as only the string. So you see the owl, so you say this in CNL by every single thing has name, nothing but some string value. I don't know if you were expecting this, but if I ask again to the reasoner, I ask again something, it's still inconsistent. And this is, maybe it's obvious, maybe not. It's because I have said that hasName should always have as range some string value, while here I have written that John hasName equals to 11. So this is inconsistent because I cannot have a range string value and at the same time that John hasName equals to 11. Okay, so this is for the inconsistency. And okay, that's all. Again, if you want more info, I can give you. Then the other file, if you have this, it's open word assumption. So open word assumption is a CNL file in which I have written a very simple ontology. In this case, I have written that Barack is a president, John is a common man, and then I said that every common man is a man, every president is a man. So in this case, you can ask a query to the reasoner and say, well, what is and that is not present. So what you would expect from this query? Logically, I would expect to get back Barak because get back John, because for us it is logical. It seems logical. In reality, this is logical, and for a reason that uses open word assumption. So more than it's not logical, this is not intuitive. So what is happening here? What is happening is that I asking a query in which I say, okay, tell me who is not a president, and the reasoner gives us no one because he doesn't know that common man and president are distinct things. So until you don't tell him, look, these two things are completely different. For me, these two things create a disjoint set. Until you don't say this to the reasoner doesn't know this. So then, when you say this to the reasoner, he will tell you, oh, look, John is not a president. But if you think about it, this is more something that you have told him. So this is to show you the limitations that you have while using this kind of reasoning. This doesn't mean that this is generally not a problem, just that it's very counterintuitive, and so often people have problems with this because it's difficult. We are not thinking like this. We automatically divide the word into disjoint classes. So this is why generally this is complicated to follow. And okay, so when you want to reason over ontology, you can spend a lot of time trying to model this kind of to overcome this kind of open word assumption. And okay, so this was for open word assumption, and this is just showing you this is normal reasoning. So reasoner. So there is nothing strange in what you see here. So this is Hermit and comes from the old API, so it's not something that is related to our CNL or something. It's DL. Then next, the next one I want to show you is the file that is called role restrictions. So role restrictions is a file that shows various possible ways in which you can restrict a role. You probably already know if you are using ontologies and OWL or RDF. And so what is I think interesting in this example is I want to show you what the role restriction is doing on the properties and things you are writing when you reason over the ontology. So this ontology is very simple again. So we have John that is a man, then John has child Luke, John has child Mary, Mary is a sad person, so she is very sad, and Mark is a man. And then I've written that every man has child a happy person. So in this case, I don't know if you've seen before, but I asked who or what is Luke? Nothing. Luke is no one. Then I asked who or what is Mary, and I get back that Mary is Mary, okay? And then that she is a sad person. Then I can ask, for example, who or what is I can ask, for example, has child happy person. As you see, we get auto-completed by to enter the things that are written in your ontology. So I asked, who or what is child happy person? You were expecting Mark inside the result set? I don't think so. So why Mark is in the result set? So we have asked who or what is child a happy person, and we never said anywhere that Mark has child something. So this is because if you look at this sentence, this this sentence is saying something like that. Every man has child a happy person. Is really stating that all the men in the world, in our world, will have child a happy person. So you have not. The written is not actually telling you that that Mark has some child and that they are a happy person or things like this. It's just stating what you have told him. So he's telling you that you have said that every man is child a happy person. So it's enough to be a man in order to have child a happy person. Then, if we change, for example, this sentence and we change it to this other sentence, for example. What this sentence is, so it's saying that every man has tried nothing but happy person. What does it mean? It means that you have that man is a subclass of object all values from something that has child happy person. As you see before, I don't know if you have seen I will show you maybe again. The difference is that here, the difference was that here was object some value from, and here you have object all values from. So it's a bit tricky, the difference. So as you will see, if we ask now again, well, what is child a happy person? Oh, Mark is not here anymore. So this sentence is not implying that Mark, that if someone is a man, then he has child a happy person. But furthermore, if we ask, for example, who or what is married, we will get that in the result test. We will get that Mary is a sad person and a happy person. So I don't know if you were expecting this, but it is. She is a sad person because we told in the ontology we wrote this. She is a happy person because this particular sentence, so the all values from, is implying that everything that will be, every time that the reader will find on this side, on the left side, a man, and then a property that is called as child, and then this will always imply that on the left side, the things that are on the left side are happy persons. So this is why Mary is a happy person, and why, for example, Luke is a happy person, as you see here. While at the beginning I was asking about Luke and he was no one. So now he is happy. So okay, this is to show you what you can do with when you are restraining, you are putting restrictions over roles. Just as a side note, I will want to let you see that this is in Siena. This is a way in which you can express SWRL rules, Swirl rule. So if you see here, this sentence this particular sentence can be rewritten as a Swirl rule. So you can say that if a man has child a thing, then the thing is a happy person. So this is a way in which you can rewrite this. But okay, it's a simple expression. But then another thing that maybe is not 100% clear is that these two sentences are complementary. So if you use them, they are not separated. So if you use both of them at the same time, what will happen? It will happen that on the one hand we are constraining the right side, so we are saying that Luke is a happy person like before, and on the other hand we are also constraining Mark to be someone that is a happy person. And again, this is some values from and as child happy person, and this is all values from. So this is the difference between these two kind of role restrictions. Then there are many other ways in which you can restrict roles, but in this case I will go only for these two. Okay, so this is it for the role restriction. And I will go now to the file that is called HasKey. So HasKey is an interesting file for this. That in OWL2, it's inside the standard, And it's a way, in reality, it's a useful way that you can use to overcome, to locally overcome the unique name assumption. And so sometimes it will help you also to overcome open word assumption. So in this case, you see, I can, in CNN, you can write a sentence like this, like, every X that is a person is unique if X has ID equal to something. If you see the XML preview, this in OWL is translated to HasKey, class person, and data property has ID. So what does this mean? This means that if we ask here, for example, what is John? Yes, what you will expect. But I can show you that we get back that John is equivalent to everyone. Why? It is because we have said this sentence is saying that if someone is a person, so this is an instance of person, great, so it's here. Then we say if someone is a person and has this property that is called has ID equal to some value, and in this case our value is 11, then is unique. So it means that as you see here, all of them have these values the same. So they are all the same. If, for example, we change one of them and we ask again the reasoner, you see that Mo is not the same as the other anymore, because this is using this deciding if things are unique like this. This can be very complex, so you can add here has many properties and as you want. So you can go on and say, for example, has name. And so if we will do again this and up. Oh, yeah, okay, maybe I didn't wrote this correctly, but it's working. You can, I can tell you. So then, next. The next one I would like to show you is it's called RL profile, ENCNL. So this file is interesting because it's showing you sentences. In this file there are only sentences that are not in RL profile. This is generally tricky to understand what is in RL profile, what is not in RL profile. Most of all, also, what is RL profile? So RL profile is this profile that is used. We have implemented this in Fluent Editor. It's implemented also in our server version on Ontology, and it is a profile I was showing you before, a profile, an OWL profile that is has been created for fast reasoning. So in RL there are some limitations and things that you cannot express. And in Fluent Editor you have this button called Validate All to RL Plus. And in this case you see all these sentences have been are in color. And if you click underneath, you will see why they have been colored. So just quickly, I will just go again here and say any idea why, but this is something you can imagine, because if you think that RL should work for rule reasoners, so in this case the rule reasoner should create a new some kind of temporary instance in order to reason about some element 1 or things like this. So in general, if you start to look at this, things, it can be you can maybe start to think why these have been are not in RL. Still, one thing that maybe you could think is, but if RL is like this, if this kind of thing, I cannot say this kind of thing. No, you cannot. But we can assure you that you can express many things using RL without the need of these sentences. And sometimes some of the sentences you can think of but I am speaking here for efficiency, can also be rewritten in SWRL. Not all of them, but some of them can. So in general, it's a quite expressive profile, but it's interesting because it's someone has taken the time to find a profile in which reasoning is efficient. And so if you if you follow the things that are in RL, you will see that reasoning will go much faster. So again, just because maybe I was too fast, validate all RL plus is the button that is here in home, and when you click it, the ontology is validated using RL, the O2 RL profile. Okay, so this is all for this, and this was RL profile ENCNL. Then I have another example that is to show you the what limitations you can think you can have while using the RL profile. So in this case, I have opened this file that is called mybooks.encnl. And this file, as you see, I have a very simple ontology in which I have just written that every book has number of pages 1, some integer value. So this is saying that I cannot have more than one value there defined. I have only one. Then we have that Pride and Prejudice is a book, Crime and Punishment is a book, Atonement is a book. And then we write sentences like Pride and Prejudice has number of pages equal to 272. Then we say that Crime and Punishment has number of pages lower or equal to 500. Atonement has number of pages lower or equal to 443. And this also has greater or equal. So let's start by seeing what happens. Okay, I have clicked all to RL, and here you see these sentences have become red, so they are not in RL. So if we open the materialized graph, and materialized graph, as I was saying before, is the part in which we are materializing the things that you have written in your ontology, so reasoning, and then you can write CNL queries or SparkWeb queries if you click on the Spark tab, but in the materialized graph tab, you will write CNL queries that to the materialized graph. So in the case of the materialized graph, you have two different reasoning profile you can choose, while in the reasoner you are always using DL. In this part, you can choose the reasoning profile, so either DL or RL. So in this case, we choose RL, and what we want to do is ask what has number of pages lower or equal to 1000. So as a human being, this I have not said before. The RL profile, when there are violations in the RL profile while reasoning, you will get this warning that it say that some sentences are outside RL profile. This is unhelpful for you because at least you will know when the result is not complete, why it is not complete. And you can click here, do not show the warning for this file. In this case, we will not show it again for the file. You can also go in the option window and delete this for the whole Fluent editor. But if you don't want this to see this, you will see this here underneath. You would see in Fluent editor you will see this. You see there is this symbol, this point of exclamation mark. So another thing now that I'm looking here, another thing you can get apart from the XML preview, you can get here for each sentence you get also the description logic description of this, so you can see here. But this is right now it's not related. So again, I click what is number of pages lower or equal to 1000. So in the result set I have only private tragedies. So this maybe it's intuitive, as I have shown to you that these sentences here are outside RL profile, so they are not. These things are not used by the RL reasoner. So when using the RL profile, we have not reasoned this. But then we can say, okay, but we can change this to DL and say, okay, let's do the same thing using the full DL. So in this case, we will before reason in DL, then materialize the graph, and then make the query. So what will happen? So in this case, the DL reasoner is intelligent enough to understand that these two sentences that are here are saying, one of them is saying that atonement as number of page lower or equal to 443, and the other greater or equal to 443. So these two sentences together are saying that atonement as number of page 443. And this is why the reason using the DL profile is understanding this. But still, as you see, we don't have this sentence. And this is why. This is for the first thing I showed you. So this is because this sentence is not a sentence that we can materialize in a graph. So we cannot have this as an answer of the query. While if we go and take this query and we put it in the reasoner, that in this case is not using materialization or DL graph or things like this, it's the reasoner. So everything is in DL. In this case, you see, we get all of them, because in this case, the full DL reasoner has also understood that if you told me that this is lower or equal to 500, this means it will also be lower or equal to 100. I think this a bit, as you see, going from RL to DL to in materialization or in full DL with the reasoner, you have seen that we can go from the less complex to the more complex, but you also need to think that it's from the more efficient to the less efficient. So when writing ontologies, you probably need also to think of these kind of things, because sometimes you can write these sentences in the same way, but reasoning will be more efficient. So this is a particular example in which why you want to write two sentences when you can write only one of them. So this is clearly a simple example, but I think there are examples more complex that at the end up to something like this. So, okay, I have reached 1 hour precisely. I have still another example, but I think I will stop here. If someone has questions or things that he wants to ask, you can ask me. I can also give you the voice, and you can also speak if you want, or else you can write in the question and answer, and I will try to answer to as many questions as possible. The whole webinar is recorded. Right now we are recording it, so it will be available, I think, from tomorrow. The next week, it will be available on our page. We will send you a link with all the things. And then for the material, you also have all the material is on the link I have given you. Still, there is a lot of after the webinar, you will be I will send you the material again. So if you want. Then, if you have any questions also about, for example, Fluent Editor, what Fluent Editor is doing, or on certain, we can go on. Oh, yes, I see, yes. So the magnitude of the difference between the various reasoning. So the various reasoning are, the magnitude of difference is very big. So when you use the full DL reasoner, reasoning goes as some kind of goes exponentially, to say quickly. So as it goes exponentially with the number of I think of entities, more or less. So if you think what an exponential function is doing, it's growing very fast. So when you reason using you reason using full DL, reasoning can become very fast, can become impossible, because our DL reasoners, there is a theory that say that DL, everything that you write in DL is you can always find an answer. So this is why DL has been used, because you are sure that you can always find an answer, but in the theory there is not written how much time you need to wait in order to have this answer. So with DL reasoning it's possible to go exponential, while RL should be for most cases should be, I think, polynomial. So polynomial means that it's very fast like to say it is fast. So it's really really very fast. How can I see the blue things in taxonomy tree pane? But the blue things are keywords. So everything that you see inside these sentences, so every book has number of page 1, some integer value. Everything that is in blue is a keyword. So it's something that we are using to understand what kind of sentence you are writing. So for example, every, then we have is or a. These kind of things are keywords. So this is why they are not shown in the taxonomy tree. In the taxonomy tree, we are just showing the things you have defined. So we are showing the instances, the relations, the attributes, and the instances and the concepts. So, and you see, we build also the hierarchy. In the taxonomy tree here, we are using what is called the structural reasoning. That is a reasoner that is reasoning very fast, but it's not complete. So if you want a complete reasoning, you need to click on this button, and this button will use Hermit to reason over to reason in order to have a complete taxonomy. I don't know if you are using Protege, but in Protege there is a similar way to do these kind of things. Where you can see the keywords. So if you look at in the Fluent editor, there is a file, and then you have help. This is generally something that no one looks at. So if you click then Fluent editor help, a window like this will show. This window has the full documentation of Fluent editor. So here you have grammar in the top. You see this grammar. So if you click on grammar, you will get that description of the CNL grammar. So it's quite complete. So you have all CNL, how each sentence of CNL is related to all sentences or Swirl sentences. Then we make some examples and things like this, and it's quite complete. You have also very complex things, like for example in CNL you can express data type. So for example you can express sentences like this, and we show the translation. We have implemented also built-ins. So right now we have implemented comparison built-ins. So in this example, for example, is showing the comparison built-ins, how to use them, and many more things. You will find the grammar, and then you have the help, and the help is more showing in general things about Fluent editor. So for example, you have most of the things you have not seen. So but what I have shown you, let me see. Oh, the reasoner, for example. If you click on reasoner, you will see how to use the reasoner. You will see this feature I have not shown you, that you can you have memory of the latest queries you've made and things like this. So yeah, now Fluent editor has quite a lot of features, so I will not go into details of all the features. So let me see a bit here. We have some other questions. So this we answered. Okay. say, I would like to know how to create and reason about the restriction set in the editor. But this is, so if you want to know, so in order to use Fluent Editor, you can go to our web page, you can download Fluent Editor. Fluent Editor is free for, it's free of use for university and non-commercial use. And then you can, if you are using it in the free version, you will have some limitations. For example, the ontologies cannot be too big, or I think some features are not allowed. You cannot click on them. Features I not showed you, like protege interoperability or things like this. And then when you download Fluent Editor, you can either look at the examples we have here in the templates. Either just to start writing an ontology, you just need to start writing inside the editor. So here, if I do Control Space, I will get, apart from some sentences that we generate automatically to show you some examples, you can start by every, for example, and then to define a concept, you just need to write it. So in this case, this is already defined. So let's try, for example, man. And then I can write is, and then I say, for example, a human being. And now just I want to take your attention just to show you that now I will put the dot at the end, and you see, automatically we have created two concepts, human being and man, that are one the subconcept of the other. Then, where I can see the keyword I answered, the keywords are too specific, but yes, so in a sense, the CNL is Cognitum implementation of a natural language, a controlled natural language that interacts with OWL. It interacts with OWL, RDS, Sparkle, and Swirl. So yes, it's too specific because right now it's working in Fluent Editor, and it's not open source, if this was the question. With respect to efficiency of data loss, the two-speed database, I'm sorry, but I think I imagine what this means, some kind of rule engine, but I have no idea what is the difference between the two. But if you are interested, you can for sure write to us, and we can think about it with more time. Does the tool support other formats? For example, OBO. I don't even know what OBO is. It's very interesting, and I will write this down and see. No, right now the tool is supporting OWL, RDS, and CNL. We are working for adding also the turtle format and the triple and N3 format. But for the moment, these are the formats supported. And you can import ontologies by clicking in the import button. And our first concern is compatibility. So we are testing a lot to be sure that things are compatible with the standards. So if you want to pull compatibility, you generally need to click on camel case name, because this will keep the camel case names that you define in the OWL, while Smart will try to change a bit the properties in order to look better in our CNL. So in this case, you can import, and then you can export to OWL or to RDS. Yes, and this. Then there is an interoperability with other tools we're working on, but I think that if you are interested, probably we will make some other webinar about this. Open biological ontology found in a lot of ontologies use this format for OBO. Okay, now very interesting. We will look at this. But if you say that this is it's for what you say, it looks more like looks more like an ontology that you use to write other ontologies. So maybe I can show you an example. So let me see. Yes, this one is a good example. So these are the templates we have that we use them to show what you can do with Fluent Editor really. So I open this file, and as you see, we are fully supporting the standard. So you can define namespace, and this will appear in the OWL when you export this, and you can reference other ontologies. So if the OBO, I don't know right now, but if OBO is some kind of ontology that you use to build other ontologies, then you can use it in this way. So here, for example, I am using book that comes from BibTeX, and so it is defined in BibTeX. And so then I can do everything I want with this. I can create new concepts using, create sub-concepts, properties, everything. And you have also a way to go around its reference explorer, and you can look at the things you have inside ontology. So for example, here we show the namespace and show the concepts and attributes that are defined inside. And you incredibly, and we autocomplete this. So you see here we are autocompleting from all the things we have imported and things like this. And then and then again, here you have also the possibility to, in this case, you are importing because there is so this, or without this, you will only reference this. Okay, so although it's a syntax-based ontology, very nice. We will study this. Great. We will look into this, and we will see if it's possible to make some way of using this. It's a very good idea. We are always open to new ideas. So thank you for this. I didn't know this. Then, do we have a macOS version? No, we don't. Right now we have. We are trying to make this. It's quite complicated because everything we are doing is in .NET. So the server version of Fluent, the equivalent version that is a server version of Fluent Editor, that is called Ontology server, can run in both Linux or Mac or Windows because it's pure .NET. In this case, being as we are using WinForm that is not compatible with, we have no macOS version. You can install a virtual machine and install Fluent Editor. Otherwise, we are working to port it to macOS, but at the moment it will be some time before we have this ready. When including ontology, should you use CNL for speed? No, CNL is not really for speed. It will not speed up your ontology because you use CNL. CNL is more simple interface to your ontology. So, for example, if you have a lot of OWL ontology, you can just interact with your OWL ontology using CNL. If you import it in Fluent Editor or reference it, like here, then you can use them inside and to create other ontology or to see what you have inside, for example. And then the CNL is a very nice interface because generally it's more intuitive for people to understand this. And we have much experience working with people who are experts of their domain that are that manage to learn CNL and then are helping us by creating ontology that of the arguments they know about that then we use for the system we are building. So the idea of CNL really is helping people to use these technologies that can be very complex to understand. And then the whole idea is, it's more or less what you can think of system. So that everything we do is trying to be as simple as possible, so that the use is as simple as possible. Okay, so I think that I don't see any other questions. I think I maybe spoken too much. Do you have any graph database connectors? Inside here, Fluent Editor is not connected to a graph database. Materialized Graph is working on the fly. And Fluent Editor is working in memory. So everything you see is in memory. So ontology, materialized graph, the reasoner, everything is in memory. And this is the desktop version of our products, and you have a lot of features and things like this. But more or less all, if not, yes, I think more or less all, just the little things are not, are also implemented in a server version that is Ontology. And Ontology server is, yes, you can think of it as the same as Ontology. So you can think inside, you can put inside ontologies, you can retrieve them by Sparkle, by TNL, you can have interaction that you see here are similar with Ontology and things like this. And Ontology is using a graph database because being scalable and it's thought for managing big scale ontology. So yes, it's using a graph database. And so Ontology has a graph database connector. Right now, connectors are with Virtuoso, with Python, and we are currently implementing one with Oracle. But we have a couple of others now. I don't remember. And it's very simple to implement a new connector. So if you have some favorite graph database and you are interested in Ontology, we can speak about this and we can show you. Okay, then maybe I will, well, we'll finish the presentation by also, can we use palette? Very good question. So yes, you can. We have added right now, there is the possibility to change the reasoner. You have in reasoners, you have here info on the reasoner. It will show you the reasoner you are currently loaded. And the reasoner can be changed. By default, there is only Hermes. The way to change this is a bit involved, so I can, if you are interested, you can write us an email, or maybe we will write to you an email. It's involved in the sense that you need to download some DLL that we have in our project that is called owl.net or .net. And then from this, if you put this DLL in the reasoner folder, you can change to PAL. Just be careful because we started to do this and some things were not working perfectly, so we will be very happy to hear your experience with it. Okay, then maybe one thing that can be interesting is that we have also created an R package that is using the Semantic Technologies and using which you can create plugins, R plugins, and then when use this plugin in Fluentizor. But you can also use this as a standalone tool, and this is called R Ontology. You can find this if you are interested. You can write to us, and we will tell you everything about this. And so when you click, for example, here I clicked enumerate universe. And in this case, what has happened is just that we have gone to R, we have asked R, we have given to R the whole ontology, and then we got back how many concepts and how many instances have been found. This is very simple, and you see we have also modified the ontology with this content. This has been generated by the enumerate universe R plugin. We have also implemented a draw ontology graph, and you can see this when you open Fluentizor. If you are interested in developing new plugin, you can just click here, and you will see the documentation for this, how you can develop a new plugin. And I think this is very nice. And if you are interested, if you want to develop these kind of things, also let us know because we will be very happy to help you or to hear what kind of things you are interested in doing. We are using it a lot, and it is very possible. Okay, great. So I will stop here. I thank you very much, all of you. I hope you liked, and if you are interested in other things we are doing or one of the things you have seen, don't hesitate to contact us. We are always very happy to speak with people working in the field and understanding with them what kind of new things can be done or created. So we are always open to new experiences. And nothing. If you are interested to see this again, you can also see this again tomorrow morning, Polish time, around 10. But I don't think you will. So Thank you very much, and see you soon. Bye.